Here we have the same region as in the last example, so I've just left it drawn. But we are going to now rotate around the y-axis. So we're going around this axis. And so if we're using the washer method, our representative slices are going to go this way. And we're going to have this line I just drew be our big R radius, and we're going to need to subtract off the little r, which is going to come over to this line. So this size of this hole in the middle for these washers is going to change depending on that function. The secret to these is to draw a picture and look at it, because you can't just kind of memorize and do this without having a picture and analyzing what is the big radius, so the outer radius for the disc, and then what is the little radius, the radius of the hole. And you've just got to look at your picture to get those. So we're going to integrate, and now we see our little thickness for our slice is a dy. So we want everything in terms of y, and our limits of integration are going to be in terms of y. So we need to start down here when y equals 1, and we're going to go up to this point up here, which is where the y equals 2. So we're going to have pi, and that looks like this big radius over here is always going to be 2. So we can just do 2 squared minus pi. Now this little radius, it's going to be the x. If we write x as a function of y here, it's going to be the x. It's going to change as we go along here. So I need to rewrite this equation. So we're going to have 2y equals x plus 2. So x equals 2y minus 2. So another way to express that equation in terms of y, and then we see that that radius of the hole is going to be x, which in terms of y is 2y minus 2. So let's go ahead and put that on. That's going to be 2y minus 2, and that needs to be squared because it's the radius squared. And then our little thickness was dy. So as we work this integral, we'll factor the pi out in front. We're integrating from 1 to 2, and this is going to be 4. When we multiply this out, and this negative will apply to each term here when we multiply it out. So that's going to be minus 4y squared, and there's minus 4y twice, so minus 8y, but this negative distributed to it will make it a plus 8y. And last times last will be 4. Distributing the negative would be negative 4 dy. So we can go ahead and cancel the 4's, and then we can do the integration. So we have pi multiplied by, if we integrate here, we have negative 4/3 y cubed plus 4y squared. We're going to evaluate that from 1 to 2. So we have pi multiplied by negative 4/3. Putting in a 2 here, we're going to get 8. So negative 32/3 plus, putting a 2 in here, we'll have 4 times 4, that's 16. And then putting a 1 in here and then subtracting off the lower limit, that'll make that a plus 4/3. And putting a 1 in here and subtracting it because it's a lower limit will be minus 4. So now we can go ahead and simplify that. So we've got negative 32/3 plus 4/3. That would be negative 28/3. Plus, and 16 minus 4 is 12, making that into thirds is 36/3. And so that's going to be 8/3 pi.